The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. Welcome to this webinar. I think we should start in just 1 minute, so I'll let just that everybody are connected. So I will wait 1 minute for the start. I think we can start. So again, hello to everyone. Maybe I will start with the PowerPoint. Maybe to start with, let me introduce myself. My name is Mateusz Budziński. I live in Kraków, Poland, and work for Gretec Innovation as a product technical manager for structural software in Gretec, which means I'm involved in planning, development, and in general care of advanced design and design modules of advanced design. Today's webinar is related to the concrete slab design using the advanced design module. So I will do the live presentation, but before few slides. And of course, if you have any question during this meeting, you can use chat, and I cannot promise that I will answer directly, but for sure after the meeting, I will answer for all questions. Okay. I'm not sure if my mic is working well, I hope. Okay, so I will start with the PowerPoint, as I said. One comment on the beginning. This is the first webinar for today during the Advanced Design User Summit. But today we have also a second webinar that will be done by my colleague Thibaut Frete, and he will show us details related to crane moving loads, related to design of cold form sections. So if someone wants, it's still possible to register and join this webinar. So it will be 1.5 hours from now, a little bit more, maybe 2 hours. Yes. Okay. So I think I can start. Next slide. Yes, this is a short agenda, the frame plan for this meeting. There are many topics I want to talk about that are grouped in 2 parts. I will start with a short recap of the version 22 when it comes to the work with new RC Slab module. Then I will do a live presentation showing many details. So now, short introduction of what we can do using advanced design when it comes to the reinforcement of slabs. So first, we can, of course, do finite element calculation to get internal forces at advanced design. Next, we can do design calculation to get the theoretical reinforcement areas on top and bottom of the slab. And with this, we can do additional checks like verification cracks, stresses, deflections, or punch verification. For such checks, we could use either theoretical reinforcement values using the equivalent reinforcement diameters, but we can also add info about the real reinforcement by adding an info about the bars, spacing on the top and bottom. But it's important that such real reinforcement is not showed and is used for cracks and deflection verification only. So, so for detailing concrete slabs, we have developed the RC Slab module that since 2 years is available on top of Autodesk Revit as the part of PowerPack for Revit detailing. But in fact, we are developed it more last year. And it allows for, on Revit, it allows for generating reinforcement 3D cage based on the imported from advanced design theoretical reinforcement areas. Of course, we use on Revit we use Revit objects as reinforcement to create bars on Revit model. And of course, the users can then create drawing documentation using pure Revit tools, also, of course, with help of Gratec PowerPack for detailing tools, but the RC Slab module on top of Autodesk Revit use the Revit reinforcement. And starting with this year, we have this RC Slab module included in the advanced design also. So we could generate real reinforcement based on theoretical areas calculated in advanced design. In addition, you can calculate theoretical reinforcement using the strip method. And in both cases, we have at the end the 3D reinforcement cage. And finally, you can generate reinforcement drawings. So today I will focus especially on that part, that point. Now, very shortly, what are the two major working scenarios when running RC Slab module on advanced design? The first scenario is that we model the slab on advanced design. Then we do static calculations to get finite element results. And we calculate the theoretical reinforcement area. So that's the first scenario, the work on advanced design. Then we can import these theoretical areas to the RC Slab module. On the RC Slab module, based on that theoretical reinforcement area, we can get real reinforcement and drawings. The second scenario is a little bit different because on advanced design we can stop on finite element calculations and import results, internal forces from advanced design to RC Slab module. Then on RC Slab module we do calculations of the theoretical reinforcement using the strip method, and the next steps are the same as on the first scenario, so we can get real reinforcement and drawings. For the first scenario, we know theoretical reinforcement areas, so we define reinforcement either by using the manually defined zones, or we can generate it automatically. I will show it later in details. Of course, we can mix both automatic and manual methods. When it comes to the strip method, we use in fact, we divide slab by virtual strips. Strips are defined in both directions, can be defined manually or automatically, and internal forces then are integrated along each strip. Then design calculations are done for each strip, so we get theoretical reinforcement area, real reinforcement area, of course real reinforcement not only area but also bars along strips. So at the end, so in fact, no matter which scenario we use, finally we get the 3D reinforcement cage, and based on this we can generate reports, we can generate drawings for fabrics, also additional schemas. So everything that I will show you today, the live presentation. So I will start with the small model. Yes, I prepare a small model just to not lose time for modeling a calculation bigger one. So we can see it's advanced design. It's a small slab. In fact, that slab is modeled as three separate elements, 1, 2, 3 planar elements. I grouped them by using super element command. So I created one super element from that three slabs. So when I select, it's one object. Of course, I have some loads, combinations, and so on. I will not focus on these. I will go just for pure calculations, finite element calculations. And what's now? Design of slabs. Of course, for calculation, to get the reinforcement areas for slabs, we need to define two kinds of options. The first set of options are related to slab. So when I select it, on the design list of parameters, we have a lot of different kinds of properties related to design, starting with general one, steel ductility, values of concrete covers, and so on. And there are also additional parameters related to additional verification, like cracking, deflections, or punching shear. Note that, as I said before, the basic calculation of reinforcement of the advanced design is for theoretical reinforcement areas. So for this, some checks like cracking can use the equivalent diameter on top and bottom. But if we want to get more detailed verification of deflections and cracking, we can define on top of advanced design also reinforcement. As I said before, the reinforcement can be defined as, let's say, rear reinforcement with defined by us diameters and spacings in both directions. We can use also fabrics. We can define our additional zones, but that reinforcement, even it's called rear reinforcement, is not displayed in any way. It's not. We cannot get any detailed information about the number of bars and so on. So that's rear reinforcement is used only for that two kinds of checks. Of course, not only parameters from the property list are important. For slabs, for in general RC concrete design, we have a set of parameters on the calculation settings dialog. I will not explain each parameter. Of course, just few info related to planar elements. So we'll use automatically select the calculation method. Just, for wood method is used for typical slabs with bending moments. Capra method is used automatically when we have forces, shell forces. Baumann method is used mainly by German appendix. So no matter which method we select, the differences will be not big. So I'll keep everything by default. I will not change anything. I will do quickly the design calculation. So yes, I will select a slab to quickly reinforcement calculations. And now, of course, I can check reinforcement areas. So as you can see, there are some areas. It's bottom reinforcement in X direction, and the same on the Y direction, and similarly for top reinforcement we will have also other values. I can use a new option because I'm using the 22.1 version, so I can use the isomap displaying method. So maybe maps will look a little bit different, but still nicer than before. One comment, as you see, for example, now I'm displaying the bottom reinforcement in X direction. So we have some values inside the span, but there are also values bigger than 0 on remaining areas. Note that on the parameters, design parameters, we have different parameters, and one of is coverage of minimum reinforcement option. It means that now it's set as entire element, so the minimal reinforcement is set to the entire area of the slab. We have also an option on tension areas only, where the theoretical reinforcement calculated is bigger than 0. What does it mean? It means that if I have selected this, probably I will get some places with 0 reinforcement required, because the minimal reinforcement will be not defined on places where there is no any reinforcement needed. This is the default settings, entire element, so just, you know, that's why even for the top reinforcement, because probably for the top reinforcement it's not necessary to have reinforcement in all places. But anyway, on that example I have like that. Okay, what next? The main topic of today's webinar is to show how we can work with the RC Slab module, new RC Slab module. First we need to open it. So I go to the design and tap on the pilot on the project browser. I select that slab. I have slab, I just open it. So I will open it on the new module. Of course, the first running of the modules always takes time, so we need to wait a little. And we see that the model is imported. What is important, in fact? First, geometry. We should know that the geometry, you can see, my model was one slab with just several columns and wall. But if it's a multi-story building, we'll see only slab and supports from that selected slab. So even I have many levels, only similar part of the model will be imported. Next point is related to the elements we can see, because on the geometry dialog on the top, you can see details about the beams, columns, walls that are imported, but I cannot change them here because they are just imported as additional info. In opposite way, I can change a little bit slab geometry. Why? To explain this, maybe I will show a little bit more what is the theoretical calculation model visible there. If I zoom in a little, you can see that green line. What is it? Maybe to explain it better, I'll close for 1 minute. I'll come back to the 3D model and look. We have a model that is created by using finite element method. So we are using axis of columns to model the column. We are using the axis of beams to model a beam. And in the same slab is defined as a object, as I drawn on the model on advanced design. But in reality, in reality, the geometry of elements is a little bit different, because you know that when I look on from the top, so you can see that that's the theoretical edge of the slab, but maybe in reality it's extended over the beams, over the columns. Maybe the beams should be moved below the slab. So depending on the on the how we modeled the slab, the model in 3D, we could have we could have different needs for drawings. That's why when I open the module again, sorry, I had selected beam and column, probably even more elements. My mistake. I will close it. Sorry, I need to select only one beam. There are only one slab. So again, when I zoom it a little bit, we can see that now the geometry of the slab is not the same as the theoretical edge. Why? It's because of the settings. By default, when I go to the geometry dialog, there's a setting called slab physical contour. So by default, it's set as the priority is on extreme supports. What does it mean? I will select the identical with analytical. So the physical contour of the slab will be identical as the analytical. So you can see now is exactly the same model. The edge of the slab is in the same place as I've modeled on the 3D model advanced design. Oh, as I said before, maybe that should be the correct modeling. In the case if the slab is not correct, it should be a little bit extended, then I can use two methods. Either I can use the selection from this list. I can, for example, put the priority on beams. So now even the theoretical edge will remain the same. I extended the physical geometry of the slab to match the edge of the beam. On that, my strange model, the column is a little bit bigger. So maybe I should put the priority on columns. What's then? Then we see that the geometry of the slab is a little bit moved again. I said that's the first method because I can use the general setting, but there is also a method for manual modification of the geometry of the slab. One important note, we cannot change the theoretical, we cannot change the analytical model. The analytical model is imported and the result we get inside that analytical element. But physical contour we can modify. We can modify, for example, graphically. I can select an option on the bottom right corner. There's an option to modify the edge of the slab. So if it's the case, I can move edge of the slab a little bit one direction, the second. Of course, I can use grips on the. I can use grips. I can use. It's not maybe very visible, but I can also use that kind of moving. Anyway, I can change manually the edge of the slab, but I can also change the position of elements like supports, beams, columns. For this, I use the last command. I need to select what I want to move. If I want to move beam, I select the beam. Then, okay. I have some troubles with selecting. Not know why. Maybe I should use different. Yes. So I can now use select beam and move it on the left, on the right, according to my needs. For example, I can move. It was not the best move, I think. I can easily cancel by pressing the space. But anyway, I can select elements. I can move them either graphically or by entering value. Maybe it's 5 centimeters column to be moved. No, I pressed 50 centimeters. Anyway, we can change the location of columns, of beams, according to our needs, according to the geometry of the slab. Why it's important? It's because how you move 0, 0, 2, maybe 2.5. Why it's so important? Because when I generate drawings, maybe I will generate drawing without the reinforcement even. I can do it. So you can see that on drawings, the geometry of supports is also displayed here. Of course, the real geometry of the slab is important because of the length of bars. I can, I don't know, in any time I can measure it. I can add additional dimension lines on drawings. So that's why it's important that the real geometry of the slab is used. Okay, so I said that we import the geometry. What else? Theoretical reinforcement. As I said, it's a method. I said it on when I showed the PowerPoint that there are two methods. The selection of the methods can be done on the right top list. The reinforcement method, the frame-based, is the method when I use the theoretical reinforcement imported. So how we can see that reinforcement? There is a tab, special tab called reinforcement diagrams. And we see the diagram to the reinforcement, to the diagram for that theoretical reinforcement. Which theoretical reinforcement? Now it's on the top reinforcement on X in the local coordinate system of the slab on the X direction on the top. This is the selection on the, if I want to see bottom on top reinforcement values. And which one? When it comes to direction, Y on X. So we can see now it's theoretical reinforcement in Y direction. We can display maybe, yes, values, why not? So we see values on the scale on the left, but also we can also display values on the model. What next? We have values on theoretical reinforcement. There are several. I will not show you all details related to displaying of results because there are different methods of displaying a result in the front of the map, different ways of displaying info or labels, info about elements. There is also a special dialog opened by this strange button with several options related to the size of the legend, size of text we use, and other parameters. For example, by default, sometimes the mesh is shown, so that's the finite element mesh imported. So we see that the results are there, but sometimes it's better display result not by using the finite element mesh. So I will switch it off. Sometimes it's easier to use displaying by using grid. What does it mean, grid? It's as you see, it's almost the same, but the results are divided by using settings on the grid generation, spacing on X and Y direction. So now sometimes it's easier to display result like that. Why? Because if I want to add manually zones, reinforcement zones, it's easier to use grids than the pure, let's say, slab without finite elements or with finite elements. I will show it in 1 minute, maybe more, but now let's focus on what we can do, how we can reinforce the slab using the theoretical values we have. There are several methods. The first one is totally manual method. So I can say, okay, I want to define bottom reinforcement on Y direction, as I know that the maximum value is more than 3.5 square centimeters. So maybe I will use, I don't know, 12 bars by, I don't know, 20 centimeters or different. One zone on for whole the slab. How to do it? It's easy. Y direction. Okay, so I select the icon with adding new zones with bars along the Y-axis. And now, graphically, I can, it's not so easy graphically. I can define the zone point by point. So I define the zone. Now I define the first offset of the first bar. I put the 0 to automatically be selected. And now I can use mouse. So when I'm moving my mouse, the spacing value is changed. It's maybe not visible very well. That's on the tooltip. You can see spacing values on the top, on the blue background. So now it's 10. If I move it a little bit, it's now the 30, 40. So by moving mouse, the spacing is changing, and also the relay reinforcement value. Now I'm using the diameter 8. It's on the first third line of the tooltip. If I use the scroll bar on the mouse, I can easily change the diameter. Now I'm using 12, diameter 12. So again, using the both and using both value and using the moving the mouse, you can see if there are some missing reinforcement areas or not. I switch off the labels, so maybe it's not visible very well, but I will put it. I selected bars 12 by 30 centimeters. But if I hover the mouse over that zone, there is a small tooltip on the top. I hope you see it. So it's bottom reinforcement, one layer and one zone, and this, the reinforcement area is 3.77. So it's more that required. If I display now, I will display values of reinforcement. So that's the theoretical reinforcement. If I select the real reinforcement map, we can see real reinforcement, sorry. We can see that's 3.77 area. If I display the delta button, delta, not X, Y, we'll see that there is no missing reinforcement area. For which is used the delta. I present it on the X direction because that's the required reinforcement for the X direction. So I will do exactly the same steps as before. Quickly, I will add reinforcement area. Maybe I will not use the whole slab. I will use just a part of the slab, just to show you how it works. So I selected the first bar, now spacing. Okay, I use some spacing, and as you can see, I used the that zone I created has 1.68 square centimeters. So there are missing bars. So there is a missing reinforcement area. So when I display the delta, delta shows me what is the difference between the required and defined by me area. Of course, so in that way, I can create areas, reinforcement areas in both directions, y and x, and I can use additional zones, because for this example, I can add additional second zone to cover that missing part. How to do it? I'm doing it manually. So I'm adding a second layer. So this reinforcement you can see now, it's a one single layer. If I can display in the 3D even, why not? So it's a one layer of bars. Yes, you can see on the X and Y direction. I will go back to the diagram. So I can define a second layer. On that second layer, as it's delta X, so I need to add additional zone for bars with X direction. Maybe I will use, I will stop, sorry. I will display grids. As I said before, it's better to see reinforcement with grids. Yes, some delays. And again, I will add a zone manually using the grids, so the mouse is now, and again, I forgot to display labels. But anyway, I'm selecting any reinforcement just to show you how I can manually add additional zone in some area. There are different tabs on the top to display together, for example, that both views, the views with their defined already reinforcement and the view with zones. Of course, I can define reinforcement that way of both directions, right, like that. But there are some other, let's say, better sometimes methods. So first, I can define the reinforcement automatically, either of both directions with one layer or with multiple layers. How to do it? So first, I need to go to the reinforcement settings. This is a dialog with many important settings. I will skip now, for now, the first tab. I will go to the solution. Solution is a setting. It's a set of settings rated how I want to generate automatically reinforcement. I can define the settings for all the slab or separately for top and bottom layer. So for the top and bottom together solution, I will select first the info, what kind of the reinforcement I want to use, by bars or by fabrics. Fabrics, or it's mean wire meshes. I will use bars. Next, what is the maximum number of density layers? In fact, we have two possible selections, 1 and 2. Now I will use only one just to show you how it works. So one layer that covers 100% of required reinforcement by using bars. Okay. So when I selected that option, I press the calculate button, or the remaining reinforcement areas or the areas defined by me manually will be erased, and the reinforcement is generated automatically. So we can see it's bottom and X, bottom and Y direction, the vertical reinforcement areas, and values. Maybe I will show that dialog better. That's the reinforcement generated. One comment why we see that, let's say, empty lines. It's because of the settings. One of the settings, I said that I will skip that set of settings, but I need to come back to the general reinforcement settings. one of the settings is the generate bars inside supports. If I had selected, what will be the difference? Then bars will be generated also over the beams and the walls. Yeah, so maybe that view will be better, because now we see beams and columns. So the reinforcement was previously generated, was not generated over the beams. Now I select the option that I want also bars generated there. Next, of course, this is the reinforcement generated automatically with one layer. What does it mean, one layer? It's again, I will look it on from the side. So on the bottom you have bars in one Y and X direction, and one layer of bars for the top reinforcement. I'm trying to display it that you see that layers, but I think it's obvious. Again, there are some other different options, like if to use hooks, how long what is the length of the hook. So there are several options there, minimum bar length and so on. I will not change them, because there is no time to explain each option. But what is important is that the reinforcement I generated is a complete required reinforcement. So there is no need, if I display the for the reinforcement values, the delta will be 0. So the value is 0 because I covered all necessary reinforcement that was needed. Of course, it's not the optimal solution, because now if I display the quantity, for the steel you have 2.3 tons. So maybe it will be better to generate the reinforcement in another way. So I change the decision. Okay, I go back to the solutions and I say, okay, I won't use one layer with 100. I will use smaller area. I don't know, 70%. What does it mean? Now the module will generate again one layer of reinforcement, so bars in one diameter with one spacing on top and bottom, but will cover not all required reinforcement, but only 70%. How it looks, maybe I will show you the real reinforcement map. The real reinforcement is 3 square centimeters when it comes to the bottom and X, but when I display the delta, we see that unfortunately we are still missing some reinforcement on some areas. Unfortunately, maybe it's the case. Maybe on other areas it's okay, but now I need only to add additional zones on that areas. Let's do it. So I will add manually. Again, I will display, sorry, I will do it like that. I will go to the reinforcement diagram. I will display again the grid. So results in the grid mode. And now, as it's a Y direction, I will create I will display again labels, values, just to see what is the missing value, still missing value. So I repeat the manual adding that zone. And apologize, I forgot what point was my first point. Yes, now it's okay. No. Yes, I forgot to tell about one important thing. Before, earlier, when I create the second zone, now I was not able to add zone. There were some messages I was not reading them. But the point is that I need to add a second layer, because now I tried to modify the existing layer zone, but in fact I need to add the second one. Now I can easily add the missing additional zone. Yes, some 0. What is the spacing? If I use bars with the 10 diameter, I need to, whoa, it's really not big reinforcement required. So yes, because it was just less than 1 square centimeters required. So you see, just when I create an additional zone, additional bars are defined, so I can see them on the 3D view. Now bars are displayed by colors because we have settings related to displaying bars in colors. Maybe I should select by family. I can select, for example, I want to see only bars on Y direction. Why not? So we see now only bars in Y direction, just to see better bars I've just added by using that zone. Yeah. Of course, in any time I can modify existing zone, existing reinforcement. So if I decide, okay, I want to change that zone, I can just double click it, and a special small dialog is pop up. So then now I can change the diameter, spacing. I can change also the zone graphically. If it's the need, I can just use mouse and extend the zone. Yes. Even change the shape, not necessarily square, rectangular shape. Of course, now I'm losing the correct reinforcement, but anyway, as you can see, we can use one generated automatically zone with reinforcement that is not covered fully, and then manually define additional zones. Of course, there is also an option to define zones in both directions, directly in both layers. By default, this is the default, so 70% it will be covered by the first layer, and the second additional by 20, by 30. So again, I will redo the calculation. So as you see, I'm playing a little bit. I'm trying to show you different ways of defining reinforcement, the reinforcement cage. Sometimes when you I need to display again the reinforcement in both directions, because yes. So we see the theoretical reinforcement bottom and top, and at the top is visible much better how the program try to automatically define additional bars to reinforce the missing. So we see zones defined automatically. As I said before, if it's the case, I can modify zones. So now extended zones to that bars are extended. I can double click on any zone to edit, to open the dialog to change settings. Of course, there are special dialogues here on the ribbon to display all zones separately from top and bottom. So if someone wants, the reinforcement can be also modified here by using special dialog. But anyway, at the end, we've got the full reinforcement. What is the weight? 1.75 tons. So it's obvious that it's much better when it comes to the optimization of the weight of the steel. Again, we can play with that parameters. We can play with different settings. For example, I can use fabrics or bars and fabrics. So let's see how it looks. I will use, yes, why not, bars and fabrics. So fabrics will be on the first, let's say, layer. Additional layer will be used by bars. It means that 70% of required reinforcement area of the slab will be covered by wire meshes, and additional bars will be defined by additional missing reinforcement will be reinforced by using bars. So let's open, let's calculate it. Yes, and again, if we zoom in maybe this view a little bit, we will see that there are now it's a top reinforcement. So on the top reinforcement there are some meshes. So the position 55 is the number of the meshes. If I hover a mouse a little bit over that mesh, we see a tooltip with info how it was cut, because there are some small parts like here. So you see that that part was cut from the bigger area. That's why the number is different. It's 22.1. Maybe there is another I'm looking for, yes, this is an example when from one mesh we can cut two parts with two different numbers, 57.1 and 0.2, and the other parts are located in different places. So this is the 37.2 element, that smaller part. In addition, we can see that there are also bars. We can display results. Now we see bars for top. Maybe we can display only by layers. So we can see this is the first layer when it means only only wire meshes, only fabrics. And this is the second layer with additional bars over supports over the points that the reinforcement was required. Now I use totally default parameters. So if I select bars, we can see that there are bars diameter 8, that there are bars diameter 12. So it's a mix. Again, everything is related to settings. So there are settings, parameters, that could be either common for all directions, so X and Y and top and bottom, or I can select separately for each one. When where I can define, okay, I want to use minimum and maximum diameter from that range, I can use only one. I can say, okay, I want to use only diameter 10. So the program will try to use that diameters. Of course, if it's not possible because of some reasons the reinforcement cannot be defined automatically correctly, we will get error messages. By the way, I didn't show it, that error messages are available on the first tab. There are some messages, errors or warnings. Sometimes errors and warnings are related to the fact that the reinforcement cannot be fit with using my default parameters. So it means that I need to go there, change this, assign parameters according to needs and requirements. For example, one of settings is related to length of the bars. It's a new option that we added just a few 1 week ago, because it's I'm showing the version 22.1 of the with the update one. We've added a special part of options related to splitting of bars. To show it better, maybe I will make a simpler model. I will use bars with one layer for the top of the slab. It will be easier to understand what I want to show you. So I originate the reinforcement with one layer of bars. Yes, so you can maybe I will zoom the 3D model. And there are some bars that are longer that it's needed. How to check if there are some bars longer that required? So again, I will go back to the settings, bar splitting, and there is an option. Okay, check the maximum stock bar length. By default, it's 12 meters, but I can, if I keep it like that, I will get an warning message that there are bars that are longer. But I can also directly split bars using one of 3 methods, using the lapping, welding, or mechanical couplers. So in case, for example, mechanical couplers, I will get that 3D mechanical couplers. When it comes to bar slapping, we'll get, yes, I will select the lapping, okay, generate, and bars will be divided with maintain the lapping length. How to check where that bars are, if there are some longer bars. I believe there are, because I checked this model earlier. So we see I display maybe bottom reinforcement, and we see that there are bars here. The shorter part, longer part. We can see also that ticks, because one of the settings is to show ticks representation, just to know what is the lap length. Of course, the length of the laps can be first changed, because when we gave any zone, it was bottom or top, I don't remember. When you have any zone, when I click it, there is an option called overlapping length that is calculated automatically according to the diameter. It's according to settings, because again, on the reinforcement settings, there are lots of these settings, and one of is related to bars overlapping length. So by default, it's calculated automatically, but I can manually define some value, or by using meters, or by using multiplier of the diameter. So we can change the lapping length. And of course, when I go to the drawings, maybe it's now time to go to drawings. Yes, we can see that the bars that were divided. Yes, maybe a little bit about drawings, because whatever method we choose to generate the reinforcement, at the end you have 3D reinforcement cage. As I said before, I can play with visualization, check how the reinforcement looks, display in some ways, but at the end, if everything is okay, I can go to interactive drawings tab. By default, we have 2 drawings generated. One is for with the bottom reinforcement, with the plan of the bottom bars, and the second one is with the plan of the top bars. By default, we get some schedules, title block. Of course, the work with drawings is the same as for other RC modules, as beams, columns, footings. So maybe I'll show some options. There are some general options like how we display bars on drawings. Now we can see a setting that bars are presented as only one middle from the range of bars. If I can display all bars, maybe it's not very usable. I can display only the first bar from the list, first and last. So different ways of displaying bars, and of course, as I had by default, only by middle bars. As or on any drawings, I can edit that views. So for if there are some places where the reinforcement is not visible very well, I need to click it. I can move, I can add some additional dimensions. Maybe I miss some important info. Yes, here maybe I should put the info about the lap, but I will move a little bit that zoom, so you see we can edit that drawings a little. Now, of course, it's not AutoCAD, but we have several nice options available either on the right-click menu or with using parameters here. But also, I can define schedules. I can, this is the some default schedule. I'm using the UK setting, so depending on the country, there are different default bar schedules. Of course, I can change them. I can use different template. I can change the scale. I can add many different kinds of schedules, separate for top, for bottom, and then if it's the need, I can move and add many different. It's the same. I can move and add different schedules on drawings. Maybe for this second one, I will create another one. Just you see how it looks. So anyway, after I play with drawings, of course, I can also remove views. I can remove schedules from views. I can change the scale. I can change the the size of paper. Now it's A3. Maybe I will select A2. A2. So it's bigger. Maybe I should select maybe not A2, but A2 landscape. Sorry. Yes, I wanted to select it. I can change the scale for the slab. I can move the. It's not so easy to move the bar schedule. Okay, I'm just playing, but you see that it's possible. What next? Of course, next I can print it, but I can also save it, because I can always save it to the file DWG, so I can open in AutoCAD. Why not? I will save it on the desktop, and I will open it in one while. But one word related to the title block. Of course, the title block, the info about the drawing is also editable. Some info is displayed automatically here. And again, depend on the country, it could look different, because title blocks are saved on the DWG templates. We can browse, we can change the templates, which was the one I used. So I can use just AutoCAD to open it, to edit it. There are some articles on Advantage website when you can find some info. how to do it. Where is the AutoCAD? Yes, the AutoCAD is open. So I open the DWG file. I can change, for example, I can change the content of this title block. Of course, there are some basic skills of using AutoCAD we need, because title blocks are defined by using blocks. So we need to use the block editor, but now we can, remove, add, move elements, replace text, add your logo, and so on. As I said, there are also drawings. I can open my drawings I just created earlier. Maybe just you see. Yes. So it's the drawing generated by me, exported. Of course, now it's pure AutoCAD. Oh yes, there are layers defined accordingly. So it's not, let's say, totally stupid drawing, but we can use to edit it later. Going back to the module. I showed how to generate a reinforcement using some options, and now a little bit about the strip method, because I said from the beginning that there are two basic methods available. So in addition to the frame-based, it's the method called strip-based. If I change this, I can do it using the list on the top right, or I can change these settings using the general parameters here. But anyway, when I change this, maybe not everything changed, but when it comes to the list of tabs are different, and tabs contain different content. First difference between the strip-based method and finite element method is that for the strip-based method, we don't have the vertical reinforcement imported. But instead, we have load cases, combinations, and internal forces. So we can display, I don't know, bending moment in some directions. Yes, I need to bending moment in one on the second direction with values if I want, from each combination from load combinations. But I need to calculate reinforcement. For this, I need strips. So the strips method use strips. Strips are virtual elements. I can define them either manually, so I create strip. It's just one line, in fact. One strip is on one line. When I create it, it generates, as you see, some diagrams, how it works. So the strip has a own width, and the strip is not a diagram on the section. It's not a diagram on the section. It's a diagram of forces integrated from that width. So we see a special small sections. So depending of the settings, the strip is divided into a set of vertical sections, and internal forces are integrated from this width. At the end, if the values are integrated, we've got that 2D diagram of integrated internal forces along that strip. So if I create more strips, I can create more strips, there's no problem. Maybe I'll add another one over the column. So you see, again, if I display the bending moments map, and you see that strips. I can do, if I want to reinforce that slab using strips, I need to define strips over the columns, over the supports, in fact, over the middle of the spans. But instead of defining strips manually, I can define them automatically because there is an option to generate strips automatically. The strips then are generated along supports, along beams and columns. Of course, that automatic method works well when the slab is in a regular shape. In general, the strip method is used mainly for regular shapes of slabs. So we have two sets of strips in major and minor directions. In our case, it's in X and Y in the local direction, but in general, the names major and minor. And we have integrated forces. Now, when we do the calculation, we'll get the reinforcement areas and zones in a little bit similar way as for previous methods. So when I go to the reinforcement, we see some bars. Again, the same settings works there. So the same settings related to the how many density layers, if I use bars or meshes, the same settings are there. But in general, from that strips, we've got the reinforcement. How it's done? As I said before, we have a strip, we have the diagram of moments, and then the reinforcement is calculated. So if I select any strip, you can see that there is a diagram of the theoretical area, it's the blue, and the red is the real reinforcement. Unfortunately, in that case, I see that there are some places where the reinforcement is missing. Why? It's, again, I selected, probably I need to select two strips. Yes, I know. I had different settings on both directions. So I redo calculation again. It's finished or not? Not yet. So now, yeah, now it's okay. So we see that there was the first layer, and on the second layer, the missing additional reinforcement is added. So we can display diagram separately for each single strip. Of course, the reinforcement cage is generated accordingly. We can check the zones. The same rules apply also here. So if I want to change the width of the zone, for example, maybe I want to use that bars with the same width as the bars from the previous zone. So I can try it, do it by manual. Yes. So you see, I'm trying to change manually zones, so the bars are automatically also adjusted. Again, it's a top and bottom reinforcement. Depending on settings, we have good different areas. I don't know, with that case, it's a really big amount of reinforcement. But anyway, it's because of my settings. What next? For the strip method, the same rules related to drawings are, so we get reinforcement. But for strip, it's important that any change related to the zone can be done even manually, but it's done in the same way as for, let's say, classical reinforcement. What does it mean? If I have, because I saw that on that strip, I need always check strips, and I see that there is a missing reinforcement area over there. How can I add the missing reinforcement here? We can do it using the same method as before. So for this zone, I can add another layer with it was too much. It was too much to the module, so the module has closed. Of course, every time you do any calculations, the result is saved. It's saved on the file, so we are not losing our results. But yes, there are some problems with that slab. But I wanted to show you how to change the zone, how to add additional layer to the zone. So I added additional layer. Ooh, sorry, it was not top, it was for bottom. No, it was for top. Yes, for top, and that where bars are that direction. So I'm not sure if I click it well. Once again. Yes. Now should be okay. I select the zone and I select additional bars. Okay, maybe a little bit too much bars, but you see that for that strip I added additional zones of bars. If I look at the drawings, there are additional bars. So anyway, when we have diagrams, we should every time check diagrams if there are some missing areas. In theory, the program should automatically cover, but in practice, it's better to check it. As I said again, there are several other settings related to both methods. For example, for the strip method, there are settings related to the default width of the strip, the number of position of sections. As I said, there are some transversal sections, and by default are defined by the mesh. So if I check the strips and the mesh, I will display mesh because it's possible to display also a finite element mesh. And now, yes, the strips have the same spacing as mesh. So maybe it's not necessary to talk about. The point is that there are some settings related to meshes. There are some settings, general settings like I don't know, concrete covers. And when it comes to the settings to the reinforcement, I said before there are here some parameters. I want to mention maybe that one, placement at cover, X direction. What does it mean? It means that bars and the X direction will be the external one. So it will be defined on the cover. We should, if the reinforcement is important from advanced design, using the FM method, we should know what was the setting on advanced design for the theoretical reinforcement. But anyway, when I check the view from the bottom, from the side, you can see now that the bars and the X direction, the local system, are the external one. Yes, or the closer to the concrete cover. Now we see also a beam, so it's a strange maybe view. If I do not display beams or columns, you will see it in better way. By the way, we see that hooks are extended over the slab. It's also defined by the options from the settings. The hooks can extend also the slab thickness. Possible that for hooks, yes, there are some warnings. I said that there is a list of, there is a place where we see warnings, and we see that there are a lot of warnings related that the necessary anchor length could not be covered by hooks. So probably hooks are not over, cannot be extended over the slab into the beams. So we should always review the list of problems and react. Okay, I think that's all what I wanted to say. Yes, for that example with a lot of additional zones, with a lot of bars, we have a lot of bars here. Maybe for bottom reinforcement is better. The number of zones is smaller. Anyway, if that case, I need to do some addition. I need to move elements. And again, as I said, it's a first version this year. Of course, this is after the update. So we're trying to improve the module drawings and other things. So we want always your feedback. So if someone is trying to is using the module to produce drawings and reinforcement and wants to some new additional methods, options, or wants something to in another way as it's possible now, can contact with us and we'll try to improve it for the next release. As we did previously for other modules, for beams, columns, or footings. So now I think most of RC modules are working pretty well. We are sure that will be the same for Slab module. Of course, for the future version, we have some plans to expand with many other functionalities. But anyway, any feedback from your side will be welcome. Okay, that's all from my side. I want to thank you very much. And if there are some questions, I will check the chat. Yes, there are some questions. If the grids are orthogonal triangle grids, when it comes to the, I hope it's about the grid reinforcement. It's about theoretical reinforcement. So maybe I'll try to explain it. When we have the slab and we see the results in the form of the map, the grid is used just to show that results in that way. So it's not the same as the finite element mesh. It's no matter if the mesh is done with triangles, then the grid is displayed as a in orthogonal direction. Of course, if we have simple mesh, on that example, it's a pure regular. I don't see even one triangle, just few trapezoidal shapes. But anyway, it's quite regular. Of course, in practice, we will have we could have much more difficult, much more complicated mesh with a lot of triangles. But just the results for the finite element for the reinforcement. Reinforcement is calculated on nodes, but for displaying, even if I switch off the mesh, will have that kind of results. I can display them in grid, and the grid is used just to better display results that way. And of course, grids are very useful for modeling zones manually. And this is the second question: if the FRP bars are implemented in the module, no. That's really short. No, we can use simple list of diameters of simple bars of fabrics with the default parameters. Of course, I can adjust some data, but that's all. Okay. I don't see no other questions. Maybe if someone wants to ask the last time. There is a question. Yes, it's the question about the strip method. No, values are integrated. So when I use the strip method and the strip is defined, I need to go to the strip. Maybe I will remove all the strips. I'll create manually a single one. Maybe a little better as before. So values are integrated with the width of that strip. If the strip, the width is different, maybe you will see the values. The maximum values is 6.6. Probably when I change the width, we see that the value a little bit changed because values are integrated along that strip, and what we see on that 2D diagrams are values, of course, per meter. It's not the maximum value. It's integrated, and we see, I don't know if the unit is visible, kilonewton nanometer per meter. Another question is if could the module can be used to design concrete wall and slab connections? No, no, not yet. Let's say. So of course we can generate separately reinforcement for slab and for walls, because of course I can open the wall and design the reinforcement for that wall. Even I calculate the reinforcement, it will not see the connection between the wall and the slab. Of course, there are some settings on the wall module when I can define for the geometry the top part, upper slab, but anyway, I need to do it manually. But anyway, there is no common drawing, common reinforcement for both elements. They are treated separately, so there is no possibility to generate here reinforcement for the slab, at least now, because I don't know, maybe if you are the users who will have a lot of requests like that, we'll consider how to do it in common together, because in reality it's possible. But for now, we cannot define nodes. Another question is if you can mix strip method with the fine method. No. Now only one method can be done, can be used for the for a wall. Of course, we can do the calculation twice, one for the strip method, one for the FEM method, but not together. By the way, the finite element method based, you can define different settings and different totally different settings for top and bottom. So we can use, I don't know, bars with fabrics on bottom, on top, maybe opposite way. On bottom, we can use only one layer of bars. On top, you can use different settings with different diameters and spacing, but unfortunately, there is no mixing of calculation methods. Okay, that's all. Thank you very much. Of course, if you have any other questions, you can contact us by your local subsidiary. So I hope every time you have any, let's say, question, the answer is can be delivered quickly. As I said, in 15 minutes, there's another meeting related to the crane moving loads and cold form sections. So if someone is registered, yes, please. And I want to say thank you and goodbye.